Hello people, I'm back with another video. I know it's been a long time. Let's get to the question. I felt this question requires a lot of special attention. The question is minimum cost to convert string 1. This question was the problem of the day before yesterday. So I will be doing it now and I will be showing it. First, let's read the question. We are given zero index strings. Two strings are given, source and target. Both have the same length n and they consist of lowercase English letters. Okay, that's obvious. We are given two more zero index character arrays. One is original and one is changed, and then integer array cost. And then cost represents the uh, amount of cost, like to change from one character to other character. That is from the original of I to the changed of I. So I have to change these two. Start with string source. So there'll be a source and then there'll be a target. We have to convert the source to target by changing each character in a sequential or whichever order you want, such that the cost of I of z, original of I of j of x, and you have to do it with the minimum cost. So the question is straightforward. I'll try explaining it with a test case. This is the first test case that is presented. Don't mind if it's blurry image. I hope you guys can see it properly. So here you have the original and changed and the cost. To change A to B, you require $2 or something. From B to C, you would require 5 units. C to B, 5 units again. C to E, 1 unit. E to B, 2 units. And then D to E, 20 units. So the intuition right here would be that it's a graph question. Because here when I can convert A to B and then I can convert from A to C. So there would be B can become C. So there will be a method to convert A to C, right? So A to B is 2 and then B to C is 5. So 5 plus 2, 10. So the cost to convert from A to C would be 7. It's a kind of graph question. And then here we have some shortest path algorithms like Dijkstra. And here we'll be using the Floyd-Warshall algorithm to solve this question. Here I represented the same original and change in form of a graph. Let's check it out. So A to B is a 2. You can see here the edge cost is 2. And then B to E, there's no path between B to E. It's not a direct path. So B to C is 5 units. You can see it here. B to C is 5 units. And then C to B. C to B would be 5 more units. Again back to B. And then C to E. C to E would be 1 unit. And then E to B. E to B would be 2 units. And then D to E would be 20 units. D to E would be 20 units. Okay. We wrote this graph down. And now the question here in the test case, you can see a source ABCD. We have to convert. I'll just write some comments here. We have to convert. ABCD to ACVE, right? First, I'll try writing down a mappings from one character to other character. So the cost of going from A to B is initially 2, and then B to C would be 5, and then C to B would be 5, and then C to E would be around 1 unit. From C to E you're done, and now from E to B. E to B would be 2 units, and then D to E would be 20 units. We have this situation here. And the question is, you have to convert ABCD to ACB. Let's go character by character and let's try converting this to that. So ABCD. So what is the cost? I'll write this one below the other. It'll be easier to understand then. What would be the cost to convert A to A? It would obviously be 0. So 0 initially. And then next B to C. Here you can see B to C, the cost would be 5. And then what is the cost to convert C to B? I'll zoom in, you guys can see. What is the cost to convert from C to B? C to B would be 5 again. But then here there's a catch. C to B would be 5. But is there any way we can convert like C to B? Like, is there a more shorter path? Let us check our graph which I drew. Okay, so C to B, for what we're checking, C to B, yeah. C to B, is there any other path? C to B, there's a 5. This is one path. But then what if we go via E, like C to E and then E to B? It would be 3 units, which is cheaper. So then I would write 3, and then what is the cost to convert from D to E? Here you have a D and an E. There is no other path between these two. It's 20. So then the cost should be totally 28. Here you can see the, let me reset the whole thing. Yeah. Here you can see the cost is 28. That is the minimum possible cost. This is fine. And then sometimes, and it's also given that if at all we are not able to convert one string to another string, no like there's no character, there's no path between any two given characters. So then we would return a -1. So that's a case which we have to handle explicitly. Okay, and then here we will be using the Floyd-Warshall algorithm. It's pretty obvious by now we are using it. Here you can see I've drawn a matrix. Actually, for this question, the plan would be to create a 26 into 26 matrix because the question clearly mentions that there are only lowercase letters. Here I wrote all the letters without duplicates. So without duplicates, I wrote A, B, C, D, E. This is original. This represents this. Represents the rows, and the columns would be the B, C, E. Here without repetitions, you can see B, C, and E. And then I would use this Floyd-Warshall algorithm. Here you can see DP, the source to destination, is nothing but the minimum of the source and destination to via the third node. Like, imagine I want to go from B to C. Uh, I would like go from B to A and then A to C, and I would check from B to C and then C to C, which is obviously C to C is 0. I would check from B to D and D to C. So then each time I would be optimizing this by making sure I give the minimum entries in each row and column. So that is the way. When we code it out, we can understand in a better way. Let's start coding it out. I'll remove this. I'll remove this. So our plan was to create a 26 cross 26 matrix. So what would it be? It would be integer and then vector of, yeah, and its name would be dp. Then there would be 26 columns, I mean 26 rows, and then it would have 26 columns and rows, and then each would be initialized to max so that we can easily find. And then next, now we initialized our matrix to a 0 cross 0, I mean to a 26 cross 26 matrix. And now initially, you can see initially they're given some original change. We'll do those entries here. So let me run the for loop. Let us have a separate, like to keep the size of the vector. Source, target. Okay. So I would iterate through the whole original and changed vectors. Here I would have a thing called original, like means which is a source. Yeah. So the character source would be, it would be the original of I, and then the destination would be where we are, what we are changing the character to. So it would be changed of I, and then cost. So the cost would be, let's put it as value. So the cost of I, so this would be the value. We have these three values. Now how would we do entries in our matrix? So then what I do is dp, the dp of I and j would be equivalent to the minimum of the existing dp. We don't need to put minimum here, just in case I'm putting it. Okay, and then it would be the cost, and it would be the value that is present. Okay, so far it's good. Now we have created our matrix and we did all our initial entries. And then one more case we have to handle. If at all the source and the destination are fine, are the same. The source and destination are fine, then dp of I and j would be 0, right? Otherwise, else we would do this only. Okay. Okay, now it's all good. So now our next step would be to iterate from we have to go through all the values and find the middle node. Like here you can see x is there, right? So a to b and then b to c, and then a to c and then c to c, and then a to d and d to c. This is what we are doing here. Uh, so then I'll try, we'll use a x variable and the x will go on up to 26. So this is one outer loop. We would use three nested loops. This is the most efficient method for this question. And like the same thing here. Okay, now we have three nested loops. Then how would we update our values here? So we'll update it with this formula, the dp of source to destination. So dp of I and j, what would it be? It would be the minimum of dp of I, j, and the dp of I and the x, you can see the x value, and then dp of plus the dp of x and the destination. X and the destination. These values will be checked. And then one more, we have to do one more thing. If at all the dp of I x uh, is equal to int max, or let's do one thing. Let's, if it's not equal to, then only we would use x. Okay, then only we would do this. Yes, and now we have updated all our values in our dp string. So now let's try printing out all these values. I'll just return a default -1. I normally print out all my entries so that I can check whether we are going in the right direction or not. So let us see out. I'll write it in a separate, just for checking. Okay. I just, and if at all, only if dp of I and j is not equal to int max, that's the only time wherein I would print. Let's try running this and check what comes out. Okay, let's check the errors. Ah, my bad. It has to be the source minus a, and then the destination minus a. Same with the bottom. Let me, yeah, now we are good to go. Let's check what our values have come out. 26, 26. Let's do it. Let's print. Else we'll print -1 otherwise. Otherwise we wouldn't know what values are coming out. Yeah. Now you can see here the entries. If it's int max, then it's -1. So these are all the entries we got, minimum values. And after getting this, now we'll try converting one string to another string. Here you can see we got these entries. And now we want to convert A to A, B to C, C to B, and D to E, and then add all these values. So now I'll declare a separate value. Long answer be zero. We'll add all the values to this. So answer, just one loop is enough. So now but I would iterate to the source and the target. Okay, I equal to 0 as in source. Okay. Now we have already DP values. So what we'll do, I'll again create uh, source. So that will be the source of I, and then the destination would be B, target would be P. Now convert from A to B. We take these entries from our DP matrix which we created. This is basically a DP question. We are using the tabulation method here. And then now answer plus is equal, and if at all we see a point wherein first I'll try ending this out. DP of A and B. So minus A again. So and then I will return this as the answer. I just hope there matters here. Okay. We need to even check the base case wherein suddenly you don't get path between two nodes, and then what's the point? Then you have written a -1. So we'll handle that case. So if at all, if dp of, if this is still equal to, then we will return a -1. Okay, we actually getting a wrong answer. Where are we going wrong? I have to check that. So destination. Okay, this part is fine. We'll try debugging our code. Okay, this is fine. So we have a source edition. We'll try printing out. So we'll try printing out each time. Yeah, we didn't check the case wherein both the values are equal. See, if at all, if A is not equal to B, that's the time we would do this part. Okay, I'll bring this up. We have to handle this case also. Let's check. P of A, the source and the target of find. Ah, we got nowhere. I messed up. So this has to be inside this because we have to check if they both are not equal. If they both are not equal, that's the time where we can check whether uh, there's no path between these the two nodes. Try submitting this. Yeah, we got a solution. Then what we did here, let's try summarizing whatever we did here. Here first we created a 26 by 26 vector whose default value is int max. Then afterwards we tried updating each value. We have a source, original changed, and then after that we did the Floyd-Warshall algorithm here. This is the equation for the Floyd-Warshall algorithm. Then afterwards we check the source and destination, and if at all both are like there's no path between two nodes, then we return a -1 as we just added to our answer. Then actually this thing can be made better. The code can be made better. Here only we can update. If at all the source and destination are equal, then I would make it a 0. That's one way. Then I don't need to write it here. Okay, we messed up.